Hello friends, welcome to Learner's Planet. Friends, this is our second session for the topic straight line. In the previous session, we discussed the different forms of straight line. We discussed point, slope form, 1-point form, 2-point form. In this session, we are going to discuss some more forms of straight line. Okay, so let's begin the session. Now, next we have the parametric form of line. The equation of line passes through a given point P, x1, y1 and makes a given angle theta with the positive direction of x-axis is given by x minus x1 by cos theta is equal to y minus y1 by sin theta, and that is assumed to be r, right? Now this is the line we are talking about. Okay, and here the line is passing from the point P, that is x1, y1. Okay, and the Q is the any point on the line, that is xy, right? Now this is the angle that this line makes with the x-axis, right? This angle is theta and this line is parallel to this line, that means this angle will also be theta. We have discussed this thing so many times. Okay, so this angle is theta, this will also be theta, right? Now what is tan theta? Tan theta is what? Perpendicular by base. So perpendicular is y minus y1 and base is x minus x1. Okay, or tan theta can be written as sin theta by cos theta. So y minus y1 by sin theta is equal to x minus x1 by cos theta. Okay, now see this important thing, r is the distance between these 2 points. Basically distance between two points is given by that's r square is equal to x minus x1 whole square plus y1 minus y1 whole square. Right? So if we assume this thing to be k, then x minus x1 whole square will be k square cos square theta, right? Plus y minus y1 will be square will be k square sin square theta, right? So is it r square is equal to k square. That means y minus y1 upon sin theta is equal to x minus x1 by cos theta is equal to r, where r is the distance between these 2 points, right? So y minus y1 upon sin theta is equal to r. So we can say y is equal to r sin theta plus y1 and x is equal to r cos theta plus x1, right? Now xy, basically these are variable point and x1 y1 is the fixed point. Okay, so now we can say xy is variable point, that means any point on this line can be written as x1 plus r cos theta and y1 plus r sin theta. Okay, so for different values of r we will be getting the different points on this line, right? xy are variable points, x1 y1 fixed points. So if we put different values of r, we'll be getting different points on this line, right? So that's actually parametric form of the line. I hope you are clear. Now next is normal form of line. The equation of a straight line upon which the length of perpendicular from the origin is P and the perpendicular makes an angle alpha with the positive direction of x-axis is given by. Okay, so this is the line whose equation we have to find out, and the length of perpendicular from the origin, that is origin is this is the perpendicular, length is given as P, and this perpendicular makes an angle alpha with the positive direction of x-axis, right? And the equation of this line is x cos alpha plus y sin alpha is equal to P. Now let's find out. How do we do? We can find out the coordinates of this point, right? This point, the y coordinate will be 0. X coordinate we can find out. We have this triangle. I suppose this length is L. Now relationship between this and this is actually perpendicular and this is hypotenuse, right? This angle is 90, this is alpha, this must be 90 minus alpha, right? So perpendicular by hypotenuse, sin 90 minus alpha, sin 90 minus alpha is cos alpha, right? So cos alpha is equal to perpendicular by hypotenuse, that is P by L. So L is equal to P upon cos alpha, right? So coordinates of this point are P by cos alpha and 0 because y coordinate will be 0. Similarly, we can find out the coordinate of this point. So here x coordinate will be 0, y coordinate can be found out. This is 90 degree, this will be 90 degree, this is alpha, this will be 90 minus alpha, right? So relationship between this and this, right? This is what? I'm sorry, this and this. So this is base, this is hypotenuse, right? So cos 90 minus alpha, that is sin alpha, is equal to base by hypotenuse. So suppose this OY length I assume to be m. So this is P by m, right? So m is equal to P by sin alpha, right? So this length is P by sin alpha, this length is P by cos alpha. Okay. Now we have already discussed the intercept form of the line. So according to intercept form of the line, x upon x intercept, that is P by cos alpha, plus y upon y intercept, that is y upon P sin alpha, is equal to 1. That is the intercept form. X upon intercept on x-axis plus y upon intercept on y-axis is equal to 1, right? So here x cos alpha by P plus y sin alpha by P is equal to 1, or we can say x cos alpha plus y sin alpha is equal to P. Okay. So that's very simple, and you can maybe ask derivation of any form of line in your exam. So be very careful about it. Just practice 2-3 times because all the forms of lines are very important. Okay. Now friends, we start solving the problems. We have discussed various forms of line. We have discussed various other concepts. What will be the relationship between two slopes if two lines are parallel, intersecting, or we can say perpendicular to each other. Okay, so if the two lines are perpendicular to each other, product of their slopes m1 m2 will be -1. If the lines are parallel, then m1 is equal to m2, and in the third case, when the lines are only intersecting, neither perpendicular nor parallel, then there will no specific relationship will be derived between the two slopes. Okay, so let's start solving the problems. First problem before us is for the lines 2x plus 5y is equal to 7 and 2x minus 5y is equal to 9. Which of the following statement is true, right? So first of all, we should be able to find out the value of slope from the given equation of lines, right? Now how do we do that? See, we have one form, that is y is equal to mx plus c. Here slope is specifically seen, right? Y is equal to mx plus c. So what we do, we try to convert the given equation of line into this format, right? Initially you can convert, gradually you will you'll be doing you can do it without any conversion. Okay, so first of all, I take this line 2x plus 5y is equal to 7. We want y to be left hand side and remaining the remaining things on a right hand side. So 5y is equal to minus 2x plus 7. So y is equal to minus 2 by 5x plus 7 by 5, right? Now y is equal to mx plus c. So m is what? Minus 2 by 5. That means slope of this line, that is m1, is equal to minus 2 by 5. Now directly how can we do that? See, coefficient of y divided by coefficient of x in negative, right? Coefficient of y divided by coefficient of x in negative. I'm sorry, coefficient of x by coefficient of y in negative, that will give us the value of the slope. Directly we can find out the slope from here also. Coefficient of x by coefficient of y in negative. So negative negative will be positive. So m1 is equal to minus 2 by 5, m2 is equal to 2 by 5. That means slope of this line is minus 2 by 5, slope of this line is 2 by 5, right? Now m1 is not equal to m2, so the lines are not parallel. M1 and m2, the product is in fact not -1 because it is minus 2 by 5, it is 2 by 5. So it's not reciprocal of each other. So the product is not -1. That means the lines are even, not perpendicular. Okay, so lines are parallel, wrong. Lines are perpendicular, wrong. Lines are coincident, that means m1 and m2 both should be same, right? So even it is not there. So lines are coincident, that you might have learned in your junior classes. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. That is AX plus BY plus C1 is equal to 0, A1x B1y C1, and A2x plus B2y plus C2 is equal to 0. So if A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then the lines are coincident. Okay, so here none of these cases there, that means the lines are intersecting. I hope you are getting it. Now here the equation of the line passing through 4 minus 6 and makes an angle 45 degree with positive x-axis is. Okay, so here we can use one point form. In one point form, what is the equation? Y minus y1 is equal to mx minus x1, right? So we must be knowing the slope of the line and one point. So here one point is given as 4n minus 6. So x1 y1 is 4n minus 6 and slope of the line is 1045 degree. M is equal to 1045, that is 1, right? So directly you can put up the value in this form. So y minus 6, that means y plus 6 is equal to m x minus 4, right? And you just can simplify it, just take all the variables and constants on one side. So x minus y is equal to 10, or we can say x minus y minus 10 is equal to 0, any of them. So we have in options x minus y minus 10 is equal to 0, so that is correct. Okay, so if you are conceptually clear, you know the various forms of the line, these sort of problems will be very easy for you. You just have to identify the given data, the given information. We have one point and slope of the line, so we can use one point form, and this is the direct relation of the direct formula for one point form, and the derivation we have already discussed. Okay, now next in the line, the equation of a line whose slope is 3 and which cuts off an intercept 3 from positive x-axis. Okay, we just try to make this slope is 3, right? So this tan theta, or we can say m is equal to 3. Okay, and intercept 3 from positive x-axis. So this length of intercept is 3. That means coordinate of this point will be what? 3 and 0. Okay, now we know one point from which the line is passing through, that is 3, 0, and slope is 3. So we can directly use one point form, right? This is x1, y1, and this is m, right? Be very clear, slope is given to you as 3. So this will be actually 3. Because we take it from positive direction of x-axis, right? Now y minus y1, so y minus 0 is equal to m x minus x1. Okay, so it is y is equal to 3x minus 9, or we can say 3x minus y is equal to 9, or 3x minus y is plus 9 is equal to 0, or here from the options y is equal to 3x minus 9. So this one is correct. Okay, so that's pretty simple. Next is the equation of a straight line passing through these 2 points, right? So here you can use 2-point form, or what you can do, you can find slope of this line and then you can use 1-point form. So how do we find the slope of the line? That is difference between ordinates by difference between abscissa. So it is x1 y1 x2 y2, right? So y2 minus y1, that is 10 minus minus 6, so it is 10 plus 6, x2 minus x1, so 3 minus minus 5, so that's 3 plus 5, 16 by 8 it is 2. right? So you got slope, and you can use any one of the points, right? And you can use this formula, y minus y1 is equal to mx minus x1, right? Now the line is passing through x1 y1 also and x2 y2 also, so be careful. You can take any of these points. In both the cases you'll be getting the same equation, so not to worry about it. We have already calculated the slope, right? So whether you use this point or this point, the equation of line will be same in both the cases, right? So suppose I take 310. So y minus y1, that is 10. Do not get confused. X1, y1, these are the points from, this is the point through which this line is passing, right? And here we are having the 2 points. You can use any one of them. So y minus 10 is equal to 2x minus x1. Okay, so y minus 10 is equal to 2x minus 6, or we can say 2x minus y is equal to, or plus 4 is equal to 0. 2x minus y plus 4 is equal to 0. Now instead of x1 y1 as 3 and 10, if you had taken minus 5 and minus 6, let's see what happens. So it is y minus 6, so it is y plus 6 minus minus 6 is equal to 2x plus 5, right? So y plus 6 is equal to 2x plus 10. So further 2x minus y plus 4 is equal to 0. So in both the cases you'll be getting the same answer. Okay, so you can directly use a formula for 2-point form, that is, instead of this m you'll be doing this y2 minus y1 upon x2 minus x1, that we calculated separately. If you wish to use 2-point form, you can directly put up this value of m over here and just put up the value of x1 y1 x2 y2, and you can calculate it separately as well. Okay. So friends, in the next session we'll be taking more problems, more concepts from the topic straight line. Do revise this session and the previous one. I'll see you in the next session once again. Bye bye.